and educating about our goals and plans for the future. So without further ado, John, you're on.
And let me pause you for half a second, John, because the run up there, I forgot to mention that one of the things we like to do is for everyone to turn their video off during the presentation. If you have a question, turn your video back on and your microphone back on, and you can ask it then. But if we turn the videos off, it makes it much more obvious for the speaker to notice that he's got someone with a question afterwards. So I'm sorry, John, it's up to you now, sir. Have fun.
Thank you, Jack. Let me hit the screen share and okay. So as I mentioned, well, first of all, thank you for allowing me to speak at this meeting. And as I mentioned, Mars is one of my hot buttons. It's always been an interest of mine, even going back to the Apollo days. I had expected that after we got to the moon that we were going to start paving the way for Mars, but I was disappointed. So we are finally getting there. And what we launched back in July was Mars 2020. And that's going to pave the way for human exploration. And this picture is of the Orion spacecraft, and I'll get into more of a description of that. But it is, first of all, it's similar to the Apollo spacecraft, and then it's going to get us to the moon and then on to Mars. So just to give you a little bit more information about me, I'm a Monroe resident, have been since 1983. And of course, all opinions and commentary are mine. They're not those of NASA or JPL. I wanted to start off with this. Another NASA JPL Solar System ambassador took this great picture just a couple of weeks ago. So I wanted to share that. You can see an area of ice right here. This is an interesting video that I'm going to show. It's Curiosity, as it says, at the Martian Scenic Overlook. Can everyone hear that? Hello?
I'm not hearing any noise from, is there supposed to be noise from the video?
Oh, okay, let me stop.
I don't hear it either.
Okay. Once again, I forgot to do that. Forgot to hit share computer sound. Come on. Okay.
When the Curiosity rover climbed a ridge and the skies cleared up during Martian winter, we had the chance to take this amazing panorama.
Okay.
And I'm really glad.
Good.
Curiosity is inside Gale Crater, a huge basin made by an impactor about 3.8 billion years ago. The mountains across the crater floor are actually the northern rim of the crater. They rise over a mile above the rover. It's so clear when we took this image that you can even see a hill outside the crater that is 50 miles away. I love how you can see Peace Vallis, a channel that once held a flowing river, like many others that formed lakes inside Gale Crater. This is also the first time we could look back and see everywhere we've been so far in the mission since landing in 2012. Here's the path we took. After landing, we drove to Yellowknife Bay before we turned southwest through Darwin, Cooperstown, and the Kimberley. The rover studied dark, wind-blown sand at Namib Dune. Curiosity then weaved between the Murray Buttes, checked out Ireson Hill, and made a tricky crossing of the Bagnall Dunes before reaching the ridge where it sits today and caught this amazing view.
So I have another video. The reason why I'm showing two videos is just to show everyone the beauty of Mars. This one's a long one, so I'm not going to...
The images in this video are all real, captured by NASA's Mars rovers, directly from the surface of the planet. This is the first time Martian footage has been rendered in stunning 4K resolution. So sit back, relax, and enjoy this journey across the surface of another world. The team at NASA has given Mars informal place names, which you will see on the screen in the bottom left corner. The footage was mainly captured by the three most successful rovers: Spirit, Opportunity, and Curiosity.
I think it's magnificent to see the tire treads on another body.
The cameras on board the rovers were the height of technology when the respective missions were launched. A question often asked is, why don't we actually have live video from Mars? Although the cameras are high quality, the rate at which the rovers can send data back to Earth is the biggest challenge. Curiosity can only send data directly back to Earth at 32 kilobits per second. Instead, when the rover can connect to the Mars Renaissance orbiter, we get more favorable speeds of 2 megabytes per second. However, this link is only available for about 8 minutes each sol or Martian day. As you would expect, sending HD video at these speeds would take a long time. As nothing really moves on Mars, it makes more sense to take and send back the images.
Okay, at this point, I'm going to stop it. But from those two videos, it always strikes me that what Buzz Aldrin said on the moon about magnificent desolation, it applies to Mars as well. So Mars has always held a fascination with us. In science fiction, for example, we have H.G. Wells and the War of the Worlds. On the right, we have that infamous radio broadcast by Orson Welles, and we're coming up to the anniversary of that. And then more recently, we have Matt Damon in The Martian. So humans have always taken a look at Mars and just been fascinated by it and have wondered what's going on there. So that's why we're making that journey to Mars. And these are actual to scale. The Earth and Mars. Mars is a little bit more than 1/2 the size of Earth. We have Perseverance that was just launched. And this is a little bit about that.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
That kid, Alex, he won the contest with that name, Perseverance, and I think he perfectly described NASA. As we all know, there have been some accidents that have occurred in our space travels. We have Apollo 1, Challenger, Columbia. NASA didn't give up. NASA persevered and learned from its mistakes to bring us to where we are today. So, the distance from Earth, as you know, it's an elliptical orbit. So the average distance is about 140 million miles. Minimum is about 34. And the maximum distance is 249 million miles. So when we launch to Mars, we try and get as close to the 34 million mile mark as possible. And, you know, as we all know, Mars has a thin atmosphere with very little oxygen. 95% of it is carbon dioxide with 3% of nitrogen. And the atmosphere is only 1% of Earth's. And of course, our atmosphere is composed of oxygen and water vapor and is much thicker than Mars. But in terms of water, I'll explain a little bit later how Mars itself can help retain the water. So I mentioned before that there was a slide that was rendered possibly null based on the Sky and Telescope issue that I received today, and this is the one. So originally Mars and Earth formed 4.5 billion years ago, and it was warmer and wetter. That could be still the case, but there's a new paper out that disputes that. So 3.5 to 4.5 billion years ago, Mars could have had water, and all of these crevices within the Martian landscape could be evidence of ancient rivers. And here's what I received today. According to Arizona State researchers, ancient Mars may have had advancing and retreating ice sheets across the surface. So rivers that cut channels across the surface long ago mostly flowed underneath the glaciers, and that occurred about 3.5 billion to 3.9 billion years ago. And it challenges the theory that channel networks were carved by water flowing on the surface. So instead of those channels being cut by water flowing on the Martian surface, it was flowing underneath the ice sheets. Whether that's true or not, and which theory is true or not, I guess we'll find out in some time. So we've been interested in exploring Mars and finding out what exactly is on the planet. Starting about 150 years ago, Giovanni Schiaparelli made a map of the canals on Mars. So this is his rendering of what he saw through his telescope. And then in 1895, along comes Percival Lowell, and he made drawings of what he saw of the canals. So there is current evidence of water. In mid-2018, the Italian Space Agency detected a deep water lake in the southern polar ice cap. And researchers at USC have determined that groundwater likely exists, and it's in a broad geographic area. So if this is true and we follow the water, who knows what we're going to find? This is Horowitz Crater, where it's believed that there may be current evidence of water in these spots here. Then we have Newton Crater. These lines are called recurring slope lineae. Salt water flows in spring and summer, and these are lines where the water has flowed down underneath the surface. So there could be aquifers on Mars. Regolith, however, can substitute for a thicker atmosphere, as I mentioned before, and it could keep the water liquid. And in on September 28th of this year, Nature.com reported that there was water ice that was discovered by the Mars Express. There's salty water. The one main body and 3 others were detected. Methane gas. Some scientists have said that the methane gas that has been detected is a sign that life could have existed. It's a biosignature. The problem I have with that is that methane is, you can find it in abundance throughout the universe, and that it could be created by non-biological processes. So this is rather nebulous. Then along comes Allen Hill's 84001. It's a meteorite that contains 4 billion-year-old organic molecules, which contain the carbon building blocks of life. The organics contain the nitrogen, another ingredient that we here on Earth depend on, and carbonate minerals were found that usually form in groundwater. And we believe that the rock was blasted off of Mars about 16 million years ago by a powerful impact. It took its time getting here, so that it arrived just about 13,000 years ago. And finally, it was found in 1984 in Antarctica. So is it an indication of life based upon what they found in there and what they found here? This little guy, or whatever it is, has been in dispute for a number of years. Some scientists will say that it's an evidence of life, and others will say, no, it's just part of the meteorite. In fact, I was watching the Science Channel just a couple of weeks ago, and they had a former NASA scientist that they interviewed who said that he was positive this was a sign of life, but was told by NASA management to keep it quiet, not to publicize it. Is it a urban legend? Is it a conspiracy theory? Who knows? But he was sure that this is a sign of life. So Mars lost its atmosphere when it cooled about 4.2 billion years ago. And this was detected by a robotic probe named MAVEN. The cooling, of course, affected Mars's electromagnetic field, and that left Mars susceptible to the solar wind. The solar wind stripped away the atmosphere and left Mars as a barren planet. And this is just an illustration of the electromagnetic field. Here we are on Earth being protected from that solar wind, and poor old Mars is just having everything stripped away because of that lack of protection. The temperature ranges are pretty significant. This is a picture of Mars's northern ice cap. In the winter, it could get down to minus 195 degrees Fahrenheit at the poles. In the summer, however, if you're near the equator, it could get up to a balmy 70 degrees. But at nighttime, it gets down to minus 100 degrees Fahrenheit. So you go from Bermuda shorts to a very thick overcoat within the span of 24 hours, not even 12 hours. About 4 billion years ago, there was a huge impact, and it flattened Mars's North Pole so that we've got a flat area here. And if I wanted to walk from here down towards the South Pole for a period of time, I'm going to be walking uphill. That's how significant this impact was. And I just wanted to throw this in. I think it's a beautiful picture of a Mars sunset. So exploring Mars, we have a long history of that. These are just some of the craft that we have sent to Mars. We've got the Mars Reconnaissance Orbiter, the MRO. We just sent Perseverance there. InSight launched November of 2018. We had Maven, Curiosity. We also had Opportunity. Opportunity operated for a great deal of time. I forget exactly the length of time, but because of a major dust storm that engulfed the entire planet, the solar panels on Opportunity were coated with this dust and therefore could not get powered up by the sun. So as much as they tried, it was Opportunity just died. They couldn't bring it back to life. And these are pictures of InSight, which is still operating, as well as Curiosity. These little guys are still going. And they're well beyond, well, Curiosity is well beyond what was expected from it. This is a picture of a crater cluster. This is from HiRISE. And this is a picture of the Curiosity's journey along a clay unit. So it starts out here. You can see the tracks coming up and going down to here. This is from the Mars Reconnaissance Orbiter. It's the southern floor of Gale Crater with these interesting shapes. It's just magnificent. The latest program is Artemis. Artemis is a twin sister of Apollo. Apollo, as we all know, is a sun god. Artemis is the goddess of the moon. And Artemis, we are going, what we say is happening is we're going from the moon, going to the moon, then on to Mars. So we're going to return to the moon in 2024. And that's pretty much etched in stone. When we get to Mars, is not etched in stone. And on the moon, we know there's water. So we can separate the hydrogen and use it for fuel to power rockets and oxygen for breathing. We can establish a permanent moon base, and it makes it much easier to launch from the moon to go to Mars because the moon has only 1/6 of the gravity of Earth. So we don't need as much power to launch a rocket. The thrust requirement is significantly less. Gateway is going to be similar to the ISS in that it will orbit around the moon, and science will be conducted there. Gateway will support human and robotic access to the moon, and it will help us build the experience that we're going to need for the human missions to Mars. And as I mentioned, it's a platform for scientific discovery. And we can see that there are several partners with us. And we've got NASA, of course, we've got the European Space Agency, the Japanese, the Canadians, the Russians. So we're all contributing to having this orbiting station from which astronauts will shuttle back and forth to the moon and also shuttle back and forth supplies. We're going to do this all with the Space Launch System. It's the most powerful rocket that we've ever had, and it's capable of launching humans to deep space and support a variety of complex missions. It opens up new possibilities for payloads, because instead of having to send different rockets with several payloads, this can handle a great deal, cutting down the need for the number of payloads that have to be launched. And it's the only rocket that will be able to send Orion astronauts and heavy cargo to the moon, as I mentioned, in a single mission. This is the rocket itself. We have 2 solid rocket boosters. The engines, 4 RS-25 engines. Orion is up here. This is the upper stage with the liquid fuel. And just to give you some comparisons, it can launch more cargo to the moon than the space shuttle could launch to low Earth orbit. The thrust is 13% more than the shuttle and 15% more than the Saturn V, which, back in the 60s, we thought that was just a beast of a rocket. Well, this is even more so. And here's how it stacks up against, first of all, the Statue of Liberty, which is 305 feet tall. The space shuttle is kind of puny compared to everything else. It's only 184 feet. The Space Launch System is shorter than the Saturn V, but more powerful. It's at 322 feet, and the Saturn V was 365 feet. And here's a breakdown again of the SLS. We have the launch abort system, which we hope we never have to use, the crew module, the service module. Putting these two together again is similar to the Apollo missions. There's the service module panels. We have the core stage, just pointing out a couple of things, the launch vehicle stage adapter. There are the 4 RS-25 engines and the solid rocket boosters. It will be powered by liquid oxygen and liquid hydrogen. The capsule itself, the Orion capsule, will carry up to 6 crew members and can support astronauts traveling hundreds of thousands of miles. And of course, as we all know, Orion comes from the Winter Star constellation of the same name. This is a close-up of the capsule. We've got the 2 forward-facing windows, the command module, service module, umbilical attachment. This is the entry hatch, the crew module itself, a docking adapter, the crew module adapter, the thrusters to maneuver with, and of course the solar panels. So here's another video about getting to Mars.
Every 26 months, Mars and Earth are at their closest distance, which is about 57 million kilometers apart. During this time, if an unmanned NASA spacecraft were to leave Earth, traveling at 58,000 kilometers per hour, it would take a little over 40 days to get to the red planet. Not bad, right? Well, A quick trip would only be possible if the spacecraft followed a direct path, undisturbed by the wrath of the solar system and weight of life-sustaining resources. Unfortunately, space travel is far more complicated than a straight line. So ideally, how long does it take to get to Mars? The solar system is constantly shifting, and the orbital mechanics behind each of the planets makes space travel really complex. Because Earth and Mars have elliptical orbits, the distance between them varies considerably, and in order to send a spacecraft to Mars, the planets have to line up just right. It takes Earth 1 year to orbit the Sun, while it takes Mars about 1.9 years. So every time Mars completes a single orbit, Earth goes around the Sun almost twice. Historically for NASA, the best launch window to Mars occurs every 2 years and 2 months, or 26 months. During this time, a spacecraft can utilize what's considered the most energy-efficient path to Mars, known as the Hohmann transfer orbit. On this trajectory, the spacecraft follows an elliptical orbit around the Sun that intersects the orbit of Mars. It uses fuel to increase speed and velocity to break free of Earth's gravity field, and the spacecraft uses more fuel to decelerate in order to be captured into the Martian orbit. Then, it can ride Mars's orbital wave until it's ready to touch down on the surface. While the Hohmann transfer is considered the most efficient trajectory to get to Mars, the journey is still estimated to take roughly 260 days, or 8 to 9 months with a manned spacecraft powered by chemical propulsion. So, NASA and private companies are trying to develop more efficient propulsion systems that can get humans to Mars faster than chemical rockets used in the past. Specifically, a type of electric propulsion system that propels a spacecraft by accelerating a stream of electrically charged atoms known as ions, and a nuclear thermal propulsion system that uses low-enriched uranium as its power source. But even if we do engineer a faster way to get to Mars, a round trip is still estimated to take multiple months, and that means we also have to solve problems of human health and resource requirements during extended deep space missions. Clearly, time is just one of many obstacles standing in the way of our Martian dreams. But still, NASA says it plans to send humans to Mars in the 2030s. So, do you think it's actually going to happen? Let us know in the comments below and tell us what other obstacles you want us to explain. If you want to see more spacecrafts, check out this playlist here. And be sure to let us know in the comments what astronomical phenomena you want to learn more about. Thanks for watching.
2 comments about the video. One is, I'm always amazed when someone asks me, why can't we just go straight to the moon or to Mars? And you have to get into orbital mechanics, and that really is rocket science. I thought I had it tough with the math that I had in economics, but this is just amazing. The other thing is, as you saw, the Earth is round, despite what these flat earthers say. Some scientists and engineers are suggesting that there's an alternative path to Mars. They've published a paper suggesting that we fly by Venus first. Fly by there en route to Mars or returning to Earth. We could use Venus's gravity to slingshot past Venus to alter the course, which means if we could do that, there would be a dramatic decrease in the amount of energy needed. So you would have fuel and weight savings. It's better for the crew health because they're not out in deep space as long, and it shortens the stay on Mars. You don't have to wait for the planets to align. Plus, you can get 2 planets for the price of 1. So in addition to studying Mars, you can study Venus as well. The goals for Mars exploration. We have 4 stated goals. One is to determine if life ever arose on the planet. What is the climate of Mars? What's the geology? And then finally, to prepare for human exploration of the planet. And the strategy that's been announced is follow the water. Although Actually, in the same Sky and Telescope issue, it said not only should you follow the water, but you should follow the carbon as well. The United Launch Alliance is launching or launched Perseverance on its Atlas V. And the timeline was, well, it was launched in July. It's an 8 to 9 month cruise. And towards the end of the presentation, I have something that will show its progress right up to now. It's supposed to arrive, well, in February 18th, on February 18th. The entry, descent, and landing. They have an interesting guidance for the entry, descent, and landing. And it's also going to be utilizing a sky crane and a surface mission. It's scheduled for 1 Mars year, which is almost 2 Earth years. The landing site is Jezero Crater, which is just north of the Martian equator. So why was that chosen? Well, scientists believe the area was once flooded with water and was home to an ancient river delta. Over 3.5 billion years ago, they believe that river channels spilled over the crater wall and created a lake. And scientists see evidence that water carried clay minerals from the surrounding area into the crater lake. And microbial life could have lived during one or more of these wet times. And if so, signs of their remains might be found in the lake bed or in shoreline sediments. So this seems like a good place to go, and it seems to be a rich environment. This is an illustration of the Perseverance rover. It has a total of 23 cameras, 9 of which are engineering, 7 of which are for science, and then the entry, descent, and landing are another 7 cameras. And just describing some of those cameras, we have the Mastcam Z, which is a zoomable panoramic camera, RimFax, which is a subsurface radar, MOXIE, that will produce oxygen from Mars carbon dioxide, Pixel, an X-ray spectrometer, Sherlock, which is an ultraviolet spectrometer, and then Watson, which is a camera, and Meta, which is a weather station, and SuperCam, which is a laser micro imager. This is how the entry, descent, and landing will work. As the capsule is coming down, as it's coming down, it will take descent photos. Compare it to the orbital map that we already have. If it senses that it's going to land in a dangerous area, it will divert to another area. So we won't have the same situation that we had when Armstrong and Aldrin were landing on the moon, where they had to manually divert to a safer area. This one will automatically be taken care of. And this is how the entry, descent, and landing will work. I'll cut this a little bit short as well.
Before Curiosity can explore Mars, it's got to get there first. The last stage of the launch vehicle gives the spacecraft a final push and spins it up for our 8.5-month cruise to the Red Planet. Ten minutes before hitting the atmosphere, the cruise stage separates and final preparations for entry begin. Hitting the atmosphere at about 13,000 miles per hour, the spacecraft begins to slow down. While slowing down, the spacecraft uses its thrusters to help steer toward the landing target. We throw off weights to rebalance the spacecraft so that it's lined up for parachute deploy. After slowing to about Mach 2, or about 1,000 miles per hour, we deploy the parachute to slow down even further. Once we're below the speed of sound, the heat shield separates and the spacecraft looks for the ground with the landing radar. Once we reach an altitude of about 1 mile, the spacecraft drops out of the back shell at about 200 miles an hour. It then fires up the landing engines to slow it down even further. Once we've descended to about 60 feet above the ground and are going only about 2 miles per hour, the rover separates from the descent stage. As the rover is lowered, the wheels deploy in preparation for landing. Once the rover is on the ground and touchdown has been detected, the descent stage cuts the rover loose. It flies away, leaving Curiosity safe on the surface of Mars. One of the first things Curiosity does after landing is to deploy the mast, which supports many cameras and instruments.
Okay, I'm going to stop it at this point. Going along with Perseverance is the Mars helicopter, or Ingenuity. Ingenuity will act as sort of a scout team. It will go out ahead of Perseverance and look for places that are interesting, but also places that should be avoided that could be dangerous to Perseverance. So, excuse me, it's solar powered. And as I mentioned, it's going to fly ahead of the rover like a scout team and checking out points of interest and helping engineers on Earth plan the best driving route. Its weight is about 1 kilogram. The blades are 1.1 meters across from the tip of one to the other. And it looks like a medium-sized cubic tissue box. So it's not very big, but it does a heck of a lot. And this is the underside of Perseverance. You can see the Perseverance. Here's Ingenuity. The engine nozzles. So how are we going to get the samples back to Earth that Perseverance will be taking? Well, in 2026, a second spacecraft will be launched to Mars, and it's scheduled to arrive in 2028 and land near Perseverance. A second rover is going to be deployed, and it's going to roll over to Perseverance, collect the sample tubes from that rover and deposit them in the Mars ascent vehicle that also arrived with that second spacecraft. Then this small rocket will launch itself and the samples into orbit and rendezvous with a spacecraft that is orbiting Mars. And that third spacecraft will collect the samples and return it to Earth, where it's scheduled to re-enter Earth's atmosphere or come back to Earth in 2031, which will be interesting because if we're expecting to have astronauts on Mars by 2035, that's only 4 years. So I'm not quite sure how that's going to work out. This is what the sample canister looks like. We have the core sample, which will go into the sample tube, be sealed with this sealer, and be placed in this canister. And there are 31 sample caches in here. So we will have 31 samples coming back from Mars. This is an illustration of that Mars ascent vehicle, which will have those samples and launch to rendezvous with that third spacecraft in orbit. And again, there's been speculation that 2035 is when humans will be landing on Mars. This is one illustration of a possible Mars habitation colony. These are buildings that will be crew quarters. They will have a garden to grow their own vegetables, making them self-sufficient, an area for scientific experiments. This is a rover that they could use. This has not been finalized. I think we're at least a couple of years away from that, probably a few years away from it. One of the problems is how do you protect the astronauts from radiation? Because Mars has no atmosphere, they're constantly going to get bombarded by solar flares. There's coronal mass ejections. Radiation coming from outside our solar system will be hitting them as well. We will be getting space weather reports from NOAA and from the Space Weather Prediction Center. How can we protect them? Well, a couple of things. One is we can build the shelters to add more mass, make the walls thicker. On the moon, there are lava tubes that will provide great protection. And we could actually have bases underneath within these lava tubes, underneath the surface of the moon. And, could there be something similar on Mars? And then another thing that I heard is that water is a good protector against radiation. So if you could do it, you could have water surrounding the spacecraft and also the buildings on Mars. Some other considerations. Well, the duration is possibly 3 years. You have to get there, you have to wait for the planets to align, and then you have to get back. So there's isolation and confinement. Now, if you have 4 or 6 people in this environment for 3 years, the question is, how well do they get along? So there's going to be a lot of not a lot of psychological, but there's going to be some psychological issues that have to be dealt with. Then we have the effects of different gravity levels. The taking off from Earth, where it's 1G, going to the moon, where it's 1/6, then the transit to Mars, which is microgravity, and then the gravity levels on Mars are much less than Earth. In the spacecraft environment, microbes can change in the environment of space. And so who knows what could happen there. Taking out the trash, we want to make sure that we do not contaminate another body. So we don't contaminate the moon and Mars. So planetary defense is a big issue. if we find life on Mars, we want to make sure it's not something that came from the Earth. Then crew health is another issue as well. They're going to be gone for possibly those 3 years. And just to give you an idea, back in the early part of this year, an astronaut on the ISS had a blood clot. And what they had to do was to send a cargo ship with whatever the appropriate medicine is and teach her how to administer that medicine. This is that dust storm that I had mentioned before. Here's Mars before the dust storm, and you could see that the planet is just virtually covered by that giant dust storm. So where, here on Earth, the worst that we had was the Dust Bowl back in the 1930s. That's nothing compared to what happened recently on Mars. NASA is developing and has a prototype for a robot that can explore extreme terrain, hills, craters, things like that. So this is a short video about this new rover that's in the concept stage right now. It's as if this rover is rappelling down the side of a cliff. So the dual axle will give us much more mobility to be able to explore other areas where rovers such as InSight and Perseverance can't go. So we can learn a lot more by actually going down into steep craters and then being able to come back up and just continually explore like that. So we can explore things like these recurring slope lineae. And that's the end of the presentation. But I do have one more thing to show you. This is the up to the minute where Mars 2020 is. Um, no. Stop share. Okay, I'm sorry. I can't figure out how to get back to what I wanted to show you. It's something from NASA that's actually showing the progress of Mars 2020 in real time. It was interesting, and I apologize for not being able to get there.
Maybe you can snag it while we're chatting afterwards. Outstanding.
Thank you.
Thank you very much, John. That was marvelous. There's a couple of periods there when I thought there was a little too much dust in the room.
Oh, can you see this?
See what?
My screen?
It doesn't appear to be sharing right now.
Okay, never mind. I'm
Go
sorry.
ahead. You can do a screen share. Just reshare.
Is it the mars.nasa.gov Mars 2020 website?
Yeah, Mars 2020 Perseverance rover.
Yep, I have that up. I could share it if you want.
Oh, okay, thank you. And any questions? There we go. So it's 46.5% completed. What's that, 292,000 miles or so in total distance. From Earth, there are 136 million miles. Did I say 1,000 before? And they still have 156 million to go. With touchdown scheduled for February 18th in 120 days.
That's cool.
So if you're interested in looking for that, this is the URL up here. Check it out. mars.nasa.gov/Mars 2020.
Thank you. The speed is 62,000 miles per hour, which is nothing compared to the way I drive. And that was it.
There's other info if you go over to the sides. Huh?
Any questions for John?
Wow.
Yes, indeed.
Anybody awake?
Oh, yeah. Put a few folks to sleep.
I don't know about that. That was pretty cool. I enjoyed that.
Yes, sir. Thank you. All right. Well, we can hang out here for a little bit. Yeah, indeed. Afterwards, a visual round of applause there. And if you'd like, one of the things I was going to do is show you where the state park was, John.
Oh, okay. Yeah.
So give me half a second here to get my
I
map
really need
up.
to get there because I need help with my scope.
Sure.
I just want to say that that was a really great presentation. You started the presentation by thanking us for letting you talk. I want to thank you for talking.
Oh, thank you, Alex.
It was excellent. Very.
It was certainly my pleasure. But
Good.
Thank you very much.
You're welcome.
Okay, let me do a quick screen share here.
Looking forward to seeing you at our next star party.
What was that?
So looking forward to seeing John at our next star party if he's still on.
Yes,
Yeah.
indeed. All righty. Should have the map up now. Where are you located, John?
I'm in Monroe, so that would be.
Okay, that's down here.
Can you see my arrow?
No, but that's okay. I know you're right about here.
That's me.
Okay. So what we're going to do is we're going to just plant a dot right there. And we're going to say, hello, where are we? Malone, Watertown. I want to go. I want to be in Monroe. I want to be right there in the intersection of Monroe.
Wow, Watertown. That's way up.
Yeah. Let's see. Why am I not getting?
I could look it up.
Well, in any case, what I wanted to do was just give you a direction to Lake Taconic.
Uh-huh.
And let's do directions on Monroe. Like so. And there we are. So essentially, yeah, 84 and then up to Taconic. And
Yep.
as a little relationship here, you can see there's Catskill, there's
Right.
Kingston. So we're about halfway in between on the Taconic Parkway there. And it's right off of the parkway there. And let's do a quick shift. There
That should be easy.
down here. Yeah.
It is.
Just a little bit of a drive.
Yeah. Ignore that red dot. We actually meet in this parking area right here.
Okay.
So when you come into the park, you'll enter off the Taconic. There's a guard gate here that I have never seen anybody actually in by the time we get there. You just stay to the right, continue around here, continuing around to the right this way, past the office right here, which by the way contains the bathrooms, and into the parking lot, and we gather right in here.
Okay. Gotcha.
Yep.
Huge parking lot.
Very, very good.
Okay. I could always put on the GPS too.
Oh, that's no fun. All right.
It's Jack and I about what, an hour, 20 minutes to get there? And we're both 20 minutes from Newburgh, and you're probably about 20 minutes from Newburgh.